Can you guys hear me? Please, before we proceed, comment. Please, before we proceed, comment if you can hear me. Can hear me? All right, Kingsley can hear me. Your Yomas can hear me. All right, Kingsley can hear me. Vincent Brume can hear me. David said I can't hear you. Wisdom, yes. Okay, please said active in same thing. So majority of you can hear me. So majority of you can hear me. All right, David can finally hear me. All right, so please keep sharing our link. Make sure that people are active for this class. And if you are just joining us, please make sure you subscribe to our YouTube channel. If you are just joining us, please make sure you subscribe to our YouTube channel. All right, you're welcome, Brand. So, without wasting further time, guys, let's start the show. Majority of the people say they can't hear me. Hello? Majority of the people say they can't hear me. Can you guys hear me now? Hello? Can you guys hear me now? Okay, okay. Thank God. Now let's proceed. All right. So today we're going to do, or we'll be introducing mole concepts, atom, molar mass, and percentage mass. So quickly, what is our focus for this lecture? So what is our focus for this lecture? So we'll look at what is mole, what is atom. We are going to be identifying mole and atom in an element stroke compound. Then we're going to do simple calculation on molar mass. And lastly, we'll do calculation involving percentage mass. All right. So can you guys still hear me? Please, if you can still hear me, just comment, "Hi, I can hear you. Hi, I can hear you." Let's go. Let's go. All right. I'm glad. I'm glad. I'm glad. All right. Let's proceed now. So quickly, like I always say, who is this lecture for? This lecture is for those in the sciences. And when we say those in the sciences, we are talking about O level, including WAEC and JAM levels. All right, and also um, A level students. When I say A level student, I'm talking about all science students in their first year in the university, colleges, polytechnics. So in the nursing colleges and all that. So I believe on this live class we have some nursing students. So quickly, if you're a nursing student, my nursing students, special ones, just comment on the comment section and say nursing, 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 nursing. Good nursing students. Let me recognize all my nursing students that are connected to this live. Okay, Mickey Brown, I see you. I see you, Mickey Brown. Nursing. Okay. So quickly, if you are a jam bite, just comment. Say jam bites, jam bites. We are getting there, jam bites. Quickly, if you are a jam bites, just comment jam bites. Okay, Sunday blessing. You're welcome. Yeah, I see those jam bites. Ayo Dile, Lemars, Kingsley, Tina. You're all welcome to this section. Please, you're all welcome to this section. Then quickly, WAEC students. WAEC students. So, like I said, that this lecture is designed for all science students, including O levels, which is the WAEC and JAM level, and all A level students, all year one in school, all science students in their first year. Fidelity, you're welcome. Treasure, you're welcome. All right, so let's now dive into the course. Now, the first question is, what is a mole? Auntie, madam, sir, I want to buy dozen of egg. Now the seller will quickly get a leather bag or a nylon and put 12 eggs inside the nylon, right? Okay, what if I told the seller that I need I need half dozen of eggs? The seller knows that half dozen of egg is 6. Therefore, a dozen is a unit that quantify items, right? We all agreed that a dozen is a unit that quantifies items. So the word dozen is a unit that quantify item. And for this case, what is dozen quantifying? Dozen is quantifying egg. Alright? So if I say I need 2 dozen of eggs, if I say I need 2 dozen of eggs, I'm simply saying I need 24 eggs. Right? So the word dozen quantifies egg. Can you guys hear me? Please comment. Can you guys hear me? Let me be sure that you guys are following. Okay, Favor Nines, Wisdom, Waik. Yeah, you're all welcome to this section. So please comment if you can hear me. Say yes, I can hear you. Alright, Faith, you're welcome. You're welcome. So let me go on. Okay. I'm gonna try my best to speak out loud. Now, quickly, if we all agree that a dozen is a word that quantifies items, e.g., um, a dozen of egg, half dozen of egg, what about a mole? A mole is also a unit that quantifies items. So a mole does the same thing dozen does to egg, right? But in chemicals, we cannot say a dozen of egg. Sorry, in chemicals, we cannot say a dozen of sodium chloride. Instead, we will say a mole of sodium chloride. So when we say a mole of sodium chloride, we are simply quantifying chemicals. We are simply quantifying chemicals. Now, on this slide, I write notes. Whenever you see a number, or whenever a number is at the front of an element or a compound, whenever a number is at the front of an element or a compound, that number stands for the number of mole. Now, if we look at this question very well, we can see that we have 2 in front of NaCl. NaCl stand for mole. NaCl stand for mole. Now, it means that the 2 that is standing at the front of NaCl, which is sodium chloride, is the number of mole. Remember, a mole is a unit that quantifies item, usually chemicals. A dozen is a unit that quantifies item. A mole is a unit that quantifies chemicals. So moving forward, I said whenever you see a number at the front of an element or a compound, that number signifies the number of mole. Now, let's take a good example or a good look at this element we see. We have 4Na, 4 sodium. Now, 4 Number four here is acting as the mole. So for me to be more scientific, I would say we have 4 mole of sodium in this place. All right. So if you can still hear me, comment 4, comment 4, comment 4. If you can still hear me, comment 4. I said we have 4 mole of sodium in this compound. Sorry, in this element. All right, I'm glad. So let's now proceed. Now, if you understood what I said, now please tell me how many mole is contained in HCl? How many mole is contained in hydrochloric acid? Please comment if you understood what I just said about mole. How many mole is contained in HCl? If you understood what I said, now please tell me how many mole is contained in HCl? How many mole is contained in hydrochloric acid? All right, I'm glad. So there are 9 moles in hydrochloric acid. Why is it 9 moles? It's because it is 9 mole because 9 is standing at the front of HCl. And remember I said whenever a number is standing at the front of an element or compound, that number stands or represents the number of mole. So if I want to be more scientific, I would say that this is 9 mole of HCl, 9 mole of hydrochloric acid. Now, moving forward, let's now look at atom. Ladies and gentlemen, we said whenever an element is at the front of whenever a number is at the front of an element or compound, that number stands for number of mole. Now, moving forward, what is an atom or what is atomic number? Now, you must have seen elements carrying subscript. What is subscript? Subscript is like a number below the element, just like the way you see H2 here. The 2 is at the bottom of the hydrogen. So let's look at it. Now, whenever you see a number just below an element, right, or element of a compound, that number represents the atomic number. Whenever you see an element, whenever you see a number at the bottom of an element, that number represents atomic number. That number represents atomic number. So if you understand what I just said, say I understand. Say I understand. And what is the atomic number in chlorine? What is the atomic number in chlorine? If you understood what I said, please tell me what is the atomic number contained in chlorine. This is chlorine. Watch your screen. Watch your screen. So of course we know that atomic number contained here is 2 as well. All right. Let's proceed. Now, the next thing we will now do is the identification of mole and atomic number. Now, what this means is we are combining each of mole, which we said that whenever you see no any element or compound stand for mole, and we are also combining our knowledge of atom, which says that anytime you see a number as a subscript, that number stands for atomic number, right? Now, we can see here, okay, let me go back. We are looking at identification of mole and atomic number. Now, you can see in this element we have 2H2. So we have 2 at the front, and we have 2 acting as a subscript. Now, I can simply say that hydrogen that I'm seeing now contains 2 mole and 2 atom. So I can simply say there are 2 mole of hydrogen and there are 2 mole of atom. So are you still following? Do you understand why I said there are 2 moles of hydrogen and at the same time there are 2 mole of there are 2 atoms of hydrogen? So please, if you are lost, say I am lost. If we are still together, say I am following. I said we have 2 mole of hydrogen and 2 atom of hydrogen. If you are lost, say I am lost. If we are together, say I'm following. Following, okay? So all of you are following. I'm glad, I'm glad, I'm glad. So please, if you are lost, let me know. I'm here for you guys. All right. Rebecca said, I'm following, sir. Proceed. Okay, I'll do just that. Now, ladies and gentlemen, we are still trying to identify mole and atom, an atomic number in the compound, right, or element. Now, let's look at this compound. First of all, compounds are combination of atoms, right? It is when elements combine together, you have a compound. So compounds are combination of elements. Sorry. Okay. Now, in this case, we have 2H2O. This is a compound. This is water. Now, how many elements makes up this um, compound? We have the hydrogen and the oxygen. So let's look at this hydrogen carefully. Now, in this hydrogen, of course, there's 2 at the front of hydrogen. So this 2 is affecting both the hydrogen and the oxygen. So I can say that we have 2 mole of hydrogen. Then the subscript, it is the hydrogen that is carrying the subscript. So I can say 2 mole of hydrogen and 2 atoms of hydrogen. Then moving forward to the oxygen, I can say there are 2 mole of oxygen and there are 1 atom of oxygen. The reason why I said this is because um, oxygen has no subscripts, and because it has no subscript, what is there is 1. So if you are lost, say I am lost. If you are together, say I am following. If you are lost, say I am lost. If we are together, say I am following. I'm waiting. Okay, I'm following. So nobody is lost. If you are lost, please don't be shy. Hope said I'm following. Rebecca said I'm following. Okay. Okay, let's now proceed. If that be the case. Okay, let's now look at ferrous oxide. Now in ferrous oxide, we have 2 elements coming together to form this compound, ferrous oxide. We have the iron and we have the oxygen. Now, the question now says, how many mole are contained in iron? Is just 1 mole because there's no number at the front, right? So we assume it is what? 1. So, but what about how many atom does iron have? Is 2. We can see that 2 is acting as a subscript. Then moving to oxygen, oxygen has 1 mole as well. How many atoms now? Of course, we have 3 atoms. All right. So if you are lost, say I am lost. If you are following, because you guys will do one exercise for me now. If you are lost, say I am lost. If you are following, tell me you are following. All right. So before we start doing exercises, remember what is our idea of mole. If you go to the market and you tell the seller that you want to buy a dozen of egg, the seller will go and bring 12 eggs, right? Because dozen means 12. So therefore, the word dozen is a unit that is used to quantify items. So I said na the same thing mole dey do for here. Mole is a unit that is used to quantify what? Chemicals. Because for chemicals, we cannot say a dozen of ferrous oxide. We can just say a mole of ferrous oxide. So in that, it's all about terminology. Alright? So chemistry is easy. Everything in chemistry means something. So since everybody is agreeing that they are following, do this. Please, please, Rebecca, Kingsley, Tina, how many mole does sulfur contain in this compound? How many mole does sulfur? Just listen to my question now. How many mole does sulfur contains in this compound? Give me the number of moles sulfur contain. I'm waiting. The number of moles sulfur contains. Number of moles sulfur contains. How many mole of sulfur is there? Okay, Kingsley said 1. Ah, Bianca said 1. Sunday Blessing said 1. You people should not be talking like you are sure. Oh. Are you people sure? Evelyn said 1. Are you sure? Ogenetiga 1. Are you sure? Wisdom. But I'm seeing 2 here. Oh. Okay, another question now. What does the 2 stand for? What does this 2 stand for? What does the 2 stand for? Please, I can't see you. Ayodele, what does the 2 stand for? What does the 2 stand for? I want to know. Okay, Wisdom said atom. Okay, who owns the atom? What does 2 mole? Tina said 2 mole. Which of the elements has the atom? Come on, talk like a scientist now. 2 atom. 2 atom of what? Is it 2 atom of sulfur? Okay, the 2 stand for atom. You guys are correct. Yes, it is atom of sodium. I love this. I love this. Wow. Wow. So, in a nutshell, the 2 stand for the number of atom of sodium. Right? I love this. Yeah. So I believe now that you guys are following. Wow, 2 atoms of sodium. 2 atoms of sodium. Okay. Now, let's not do this. How many mole does carbon have here? How many mole does carbon have? How many mole is contained in this? I'm waiting. Okay, Tega said 2. Carbon has 2 moles. I love that. Okay. Now, how many atom is contained in oxygen? How many atom is contained in oxygen? 2 mole of carbon. Good. Now tell me how many atom is contained in oxygen. Okay, Evelyn says 2. You guys have just been saying 2, 2. Why can't I say 4? Why can't I say 2 plus 2 is equals to 4? Pedro, why can't I say 2 plus 2 is equals to 4? Why can't I say that? Please, if you are yet to subscribe to our YouTube channel, please do that now. If you are yet to subscribe to our YouTube channel, if you've not subscribed to this YouTube channel, please subscribe now. Okay, you guys are still saying 2. I'm just glad that you guys understood it. So let's move forward. I don't know where Bliss went to. If you are yet to subscribe to the YouTube channel, please hit that bell. Hit subscribe, hit subscribe. Okay, I've increased my volume now. Divine, I've increased my volume. Sorry about that. Sorry about that. So I was saying that if you are yet to subscribe to this YouTube channel, please do that now, because we are going to be learning just like the way you guys are learning right now. We're going to start from the basics of chemistry. Some of you, there are some things in chemistry that you guys don't understand. We are going to start all over again afresh from the basics. Alright, so and that is why you must subscribe to this channel, follow it, hit the notification bell. Now let's proceed. Now we'll now go to molar mass. Now, what is our idea? Two or more elements combined together to give us a complex structure, which is known as what? Compound. Now, when we now talk about molar mass, remember, if elements are coming together to form a compound, it means that the compound is made up of what? Elements. And if you add all the elements together, the compound becomes heavy. So when we talk about compound, we are simply calculating the total amount or the total number of mole, total number of atom of elements that is contained in a compound. So when we talk about molar mass, we are talking about the sum total of mole and atom contained of an element contained in a compound. Right? So for example now, e.g., we have the ask us a question. They say, what is the molar mass of sodium chloride? What is the molar mass of sodium chloride? And in bracket, they said sodium is equals to 23, chlorine is equals to 35.5. So they now ask, what is the molar mass of sodium chloride? Now, what I would do, the first thing I would do is to ask myself, how many element forms or comes together to form this sodium chloride? Of course, it is sodium and chlorine. Sodium plus chlorine are added together to give us sodium chloride. So what is the value for sodium? Is 23. What is the value for chlorine? Is 35.5. So what will I do? I will add 23 to 25 plus 0.5, which is 23 plus 35.5. That should give me the answer. So guys, press in your calculator 23 plus 35.5. What's the answer? Okay, Treasure said 58. Treasure said 58. If you are lost, please say I am lost. If you are lost, say I am lost. If you are following, say I am following. Let me know so that I will not, everybody will move at the same pace, so that I will not be teaching some and be neglecting some. So please, if you are lost, say I am lost. Okay, Innocent said I am lost. Okay. Okay. So the rest of you, are you following? Say yes. If you are following, say yes. Now, Innocent Beauty, want to calculate molar mass. What we've been doing since is to just identify the number of mole and the number of atom. So I just want to ensure that you guys understood what it means to say 1 mole, 2 mole, or you guys understood what it means to say 2 atoms, just like this compound, right? So what is now molar mass? When we are calculating molar mass, we are putting the number of mole and the number of atom in consideration. So according to this definition, we said molar mass is the sum total of mole and atomic number in an element or compound. Okay, so Joanne, we said molar mass is defined as the sum total of mole and atomic number in a compound. That means to say that if we have a compound, right, or we have an element that it asks us to calculate the molar mass. Now, on this element, they said, what is the molar mass of sodium chloride? And they said sodium, which is Na, is equals to 23, chlorine is equals to 35.5. And they now said, what is the molar mass? Now, how many elements form sodium chloride? They are just two. We have sodium and we have chlorine. Now, if we add it together, it simply means that we are adding their values together. So what is the value for sodium? It is 23. How do I know it's 23? Because it was given in the question. So 23 plus 35.5. Where is 35.5 coming from? It's from chlorine. How do I know? It was given in the question. Okay. Idigu, are we together now? Idigu, are we together? 23 and 35.5 came from the question. They came from the question. They came from the question. Okay, so let's proceed. Now, I don't know if you are confident to solve one or let's solve together. I don't know. I used to have a pen here, but I'm not seeing the pen. I used to have a pen here so I can solve a question, but I'm not seeing my pen. Okay, so let's proceed. Now, ladies and gentlemen, we are now giving another question to solve for molar mass of sodium sulfide. Now, sodium sulfide is Na2X. Now, that 2 stand for number of atom, and the number of atom belongs to sodium, right? So automatically they gave us sodium is equals to 23 and sulfur is equals to 32. Now automatically, because of these 2 that sodium contain, it will now be 2 times 23. That is, we have 2 sodium combining with sulfur to give us sodium sulfide, right? So we have 2 times 23 plus 32. So 2 times 23 is 46 plus 32. Everything come out 78 gram per mole. All right, I will give you guys question, but let me be sure that you guys understood this. So if you are ready for my question, say I am ready. I am ready. Oh yeah, I am ready. Let's go. I am ready. Okay, guys. I know you are ready. Yeah, stop this one for me. Quickly, quickly, quickly. So for me, SK, I see you. Official SK, I see you, SK. Okay, solve this one for me, guys. I'm waiting. Okay. Idigu says she got 98. Pedro says she got 58. Okay, Aves of Paco, I see you. Favor 9, 98. Sunday 98. Alright, I love that. Always put the units. Grandpa Mole. Ayodele, I see you. Marve, I see you. Rebecca, I see you. Yeah, Treasure said I am ready. Treasure, now stop. Solve these for me, ladies and gentlemen. Solve these for me, ladies and gents. Alright. Some people are getting 58. Okay, I believe those people they are okay, okay. Those people they are backward in streaming. Please just forward your stream so that you can be on our current stage we have. Okay. Alright, 98. Now stop this for me. The question has changed. The question has changed. Solve this for me. Official SK, I see you. Solve this for me. The question has changed, ladies and gentlemen. We have sodium tetraoxosulfate 6. And I say solve. 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 Let's go, let's go, let's go. 142, 143, 142, 143. Ladies and gentlemen, the whole point of we doing this is to just come back from the beginning of chemistry. Let's learn chemistry from the start, from the scratch. Are we together? We are learning it from the scratch. From the scratch. As time goes on, as we proceed, we keep proceeding. By God's grace, we keep proceeding, and we advance to complex topics. And when we get to complex topics, it is not going to stress us that much because you already understand the basics. All right. So, ladies and gentlemen, I guess the answer is 142. 142. Okay. All right. So, I haven't said that, ladies and gentlemen. Okay. So we are done solving. Oh, let's now introduce percentage mass. Let's introduce percentage mass. So, ladies and gentlemen, if you are just joining us, the first thing to do to be a part of this academy is to subscribe to this YouTube channel. Subscribe to this YouTube channel. All right, subscribe to this YouTube channel. That's the first thing you should do earn you a badge of a member or membership of this academy. Please subscribe, share to your friends, tell your friends, tell those writing jam that there's a platform, an academy that is giving out lectures for free, and we are starting from the basics of chemistry. People say chemistry is too hard, chemistry is too hard, and whenever I hear this, I'll just smile and nod my head because I know that's not true. So subscribe and share to your friends. We are just starting, all right? We are just starting. So, ladies and gentlemen, the next thing we will not talk about is percentage. Now, when we talk about molar mass, we agree that um, element comes together to form compounds, right? We agree that element comes together to form compounds. Now, once they form compounds, they become heavy. And if we want to calculate the mass of the compound, we have to put the mole into consideration, we have to put the atom into consideration, we have to sum everything together to get the molar mass. Are we together? Now, once the mass of a compound now involve percentage, it means that, for example, sodium chloride. I don't know if I ahem. Okay, let's look at this. We said percentage mass, also known as mass percentage or percentage composition, is the ratio of the mass of. Okay, I know you guys didn't really understand this, but let's see this. In this compound, we have H2SO4. Now we have three elements combining together to give us a compound, right? Now, in percentage mass, we want to calculate what is the percentage of oxygen that is combining with hydrogen, combining with sulfur. We want to know what is the percentage of sulfur that is combining in this compound. Do you understand? So first of all, what do you do? We know that this compound contains two hydrogen because it's two atoms of hydrogen plus one sulfur plus four oxygen, right? It is four atom of oxygen. Are we together? Now there's no number at the front, so the mole are one, 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 one. Then what about atom of hydrogen? It is two. Number of atom of hydrogen, it is two. Number of atom of sulfur, it is one. Number of atom of oxygen, it is four. Now, if we want to calculate the percentage of the individual element inside this compound H2SO4, what do we do? Like this example. Now, we simply apply a formula. What is the formula? The formula says that percentage mass is equals to mass of the component over the total mass of the mixture times 100. Why are we involving 100? Because anything percentage is 100. Now, I know you guys don't really get it. I will try and solve an example so that you guys will follow. Now, guys, look at this question. I promise you all that in our next live class, it's going to get better because I'm going to get a pointer. So that as I'm teaching, I'll be pointing my screen. Alright? So we are getting better, guys. Now, let's look at this question. This question says, calculate the percentage of mass of oxygen in H2SO4. Calculate the percentage of mass of oxygen in H2SO4. Now, given that hydrogen is equals to 1, sulfur is equals to 32, then oxygen is equals to 16. Okay. Tega said I should explain again. Now, I said once it involves percentage mass, the formula you apply is mass of the components over total mass of the mixture times 100, right? Now, the reason why we are involving 100 is because anything percentage is 100. Now, ladies and gentlemen, you might not really know the mass of the component. You might not really know the total mass of the mixture. That is why I said let's take down this example so that we can try our possible best to understand. Now they say calculate the percentage mass of oxygen H2SO4. Now hydrogen is given as 1, sulfur is given as 32, then oxygen is given as 16. Ladies and gentlemen, ladies and gentlemen, let's now work this out. It is simple, don't fear. Now the first thing you will do is to calculate the percentage mass of H2SO4. The first thing you do, or how to go about this, the first thing to do, calculate the percentage mass of H2SO4. Now, this is what I did here. The first thing I did, I calculated the percentage mass of H2SO4. Now, I said in H2SO4 we have two hydrogen coming together with sulfur, coming together with 4 oxygen. When they combine together, they give us H2SO4. Now, let's now solve. 2 times 1, where is 1 coming from? 1 is coming from the question. They gave us the value of hydrogen to be 1. Where is this 2 coming from? 2 is coming from, because hydrogen contains 2 atoms. So you use 2 to multiply the 1. That's where 2 is coming from. Plus 32. Where is 32 coming from? 32 is coming from the question. Alright. Plus 4 times 16. Where is 16 coming from? 16 is coming from the question. Where is 4 coming from? 4 is coming from the number of atom of oxygen. Now, when we sum all these together, we have, when we sum all these together, can you guys still hear me? If you can still hear me, please comment, comment, comment. My network was interrupted, but I'm back. Guys, I'm back. If you can still hear me, so I can hear you. If you can still hear me, say I can hear you. If you can still hear me, say I can hear you. I'm sorry for the interruption, guys. Alright. Alright, thank you for your patience. Thank you for your patience. Alright. So, like what I was trying to explain to you guys, I said whenever you are given a question, just like this one, whenever you are given a question just like this one, try to calculate the percentage. So try to calculate the molar mass first. Now this question says calculate the percentage mass of oxygen in H2SO4. Now the question says calculate the percentage mass. That means they are saying you should calculate the percentage of oxygen in H2SO4. Now, what will I do? First of all, I will first calculate the molar mass. Now, I calculated the molar mass to give me 98, right? After calculating the molar mass to give me 98, secondly, what will I do? Now, we are interested in only oxygen. We are interested in only oxygen. Now, still on this calculation, what is the total weight of oxygen? Is 4 times 16. 4 times 16 will give us 64. So therefore, I will say it is the value of oxygen over the total value. What is the total value? Which is the total mass. The total value is 98. So 64. Where is 64 coming from? Is the total value of oxygen alone separately over the total mass. So that is 64 over 98 will give us 0.65. Multiply it by 100, we get 65%. Please, if you understand this, say I understand. If you are lost, say I am lost. What I will try to do from our next class is to have a pointer, so that as I'm teaching, I'll be pointing out these things. If you are lost, say I am lost. If you understood, if you are following, say I am following. If you are lost, say I am lost. If you are following, say I understand. You guys, my jam student, you guys are going to pass your exam. You are going to blow the mind of jam. My PTS student, you guys are going to pass this PTS exam. You are going to blow um the council of nurses. All right. If good, I love that. Plagiary said, Amen. PTS students, I can't hear you. You say, you are my PTS students. You are my nursing students. My nursing students. Okay, Joy is coming. Joy is saying, Amen. You guys will pass your exam. You guys will pass your exam. Ladies and gentlemen, the problem most people will have is that they want to start reading chemistry from complex stage. The best approach to go in preparing for your exam, either it is PTSO, either it is a JAM, or whether it is WAECO, is that you will start from the basics, where chemistry is born. Ladies and gentlemen, this is where chemistry is born. Simple calculations like this. If you can solve simple calculations like this, then you can confidently solve the ones that is going to come later, the kind of questions I'll be giving you guys later. In this class, I'm still pampering you guys. All right. So quickly, let me quickly announce our class is now 2 times a week. Every Tuesday we'll be having a live class, and every Sunday we'll be having a live class. So um Tuesday and Sunday we'll be having a live class, so that we can be fast with our curriculum. All right, PTS student, I'm doing this because of you. Those my nursing students, I'm doing this because of you guys, so that we can be fast in our curriculum. So I have made the class twice a week, Tuesday and Sunday. So why did we use only oxygen to divide the total mass? Yes, thank you very much. Because the question says, this is the question. The question says, calculate the percentage mass of oxygen. It is oxygen alone. It is oxygen alone. All right. It is oxygen alone. The question says, calculate the percentage mass of oxygen in H2SO4. So first of all, we calculate H2SO4, right? And we got 98 since we did that. So what is the total mass of oxygen? Is 64. So 64 divided by 98 give us 0.65. Multiply it times 100, because there's 100 in this formula, so it will give us 65%. Okay, so let's now look at another example. Ladies and gentlemen, this is another example. They said, calculate the percentage mass of sulfur in NaSO4. Then, given that sodium is equals to 23, then sulfur is equals to 32, then oxygen is equals to 16. Ladies and gentlemen, they say calculate the percentage mass of sulfur. That means to say that in this compound, we are only concerned about sulfur, right? We're only concerned about sulfur. Now, what's the first thing we'll do? Of course, the first thing we'll do is to look for the molar mass of Na2SO4. So let's look for it. So step one, you can see where I label 1. Now Na2XO4 contains 2 atoms of sodium plus just sulfur plus 4 atoms of oxygen, right? So we now have 2 times 23. Where is 2 coming from? 2 is coming from the 2 atom. Where is 23 coming from? 23 is coming from the question. Plus, where is 32 coming from? It is the value of sulfur given in the question. Then 4, where is 4 coming from? The number of atom of oxygen. Then oxygen is 16. Where is 16 coming from? Is the value of oxygen in the question. So by the time we work this together, this is the calculator value. I guess you guys have done this before. You guys got 142 gram per mole. You guys did it, right? Fine. But we are not going to stop here. We are calculating percentage mass, ladies and gentlemen. So what do you do? Step 2. What is percentage mass? Percentage mass is equals to mass of the components all over the total mass times 100. Now, what is the component, or what is the element we are concerned about? What element does the question ask us to calculate? Here it is. If we go back, you see that it is sulfur. Now, what is the value of sulfur? Sulfur is 32. So it will now become 32 over 142. I believe this guy now is not getting familiar. 32 over 142. 32 over 142 is 0.225. Multiplied by 100, because 100 is percentage, you have 22.5%. Guys, this thing is very simple. When you see this in your PTS exam, when you see this in your JAM exam or WAEC, it's going to be a bonus to you guys. It's going to be a bonus to you guys, right? Bonus. So if you are ready to solve one question for me, say I am ready as usual. I am ready. Let's go. I am ready. Let's go. I am ready. I am ready. Let's go. Okay. Hope says I'm ready. Sunday Bleed says I'm ready. We are almost ending this section, so that we can come back on Tuesday. We are almost ending this section and come back on Tuesday. All right. Okay. Now, guys, stop this for me. Good. I love this. Stop this. Stop this. Stop this. Guys, solve this. Solve this for me, guys. I know my guys are now working. I love this. Solve this. Yeah. I hope you guys are working. Okay, Hope is saying we have 63%. Hope, are you sure? Now, what will I do? First of all, I'll first calculate molar mass. Now, I calculated the molar mass to give me Bliss got 63.6. Kingsley got 63.6. We are interested in only we are interested in what now based on this calculation, what is the total weight of us? Water. Water is the thing we give us. So therefore, I will value of water over the total value. What is the total value? Which is the total mass? The total value is 98. So 4. Yes, 4. On a server mo. Okay, guys. One important information before we go. Um, our chemistry live class is now 2 times a week. Tuesday and Sunday. Tuesday and Sunday. Our chemistry class is now twice a week. Tuesday and Sunday. Alright. And the reason why we are doing this is so that the PTS student can catch up and the jam bite can catch up as well. The white student don't really have issues. But I'm doing this because of the nursing student and the jam bites. Alright. Now, number two is if you are yet to subscribe, if you've not subscribed to this channel, please do that now. That is the only price you pay for being among our academy or being in this academy. All right, assignments. Then we will go. Please take down these assignments. Let's go. Assignment. You take a sorry. This is the compound NaSO4 Na2SO4 dot 10 H2O. All right, this is assignment. Ladies and gentlemen, you can just use your phone to screenshot it, work on it, work on it. In our next class on Tuesday, you guys are going to submit it before we start the live class. All right. So, any questions so far before we end the class? Any questions so far? Any questions so far? This is an assignment. Just screenshot it and work on it before the Tuesday live class. Now, before we start the Tuesday live class, you're going to submit this assignment to me. To me. All right. We are getting better. Any question? Any question? Ladies and gentlemen, let me take you back from where we're coming from. So we started by defining a mole and we compare mole to crate of eggs, right? Then we'll move forward to talk about atoms. Okay, we'll look at some examples and identification of mole. we'll look further to talk on atoms. I will start identifying atoms. Then we'll start identifying mole and atoms together. You remember we did this? Then from there we enter molar mass where we solved, and now we came to percentage mass. Ladies and gentlemen, in the absence of no other question, We are going to end the class here. We're going to end the class here. So we'll count one. I'm going to count 1 to 10 on the comment section before I end the class. No, you cannot get an option. Mavis, you cannot get an option. All right, 3 more to go for the class end. You cannot get an option. Work on it. The dots represent positive as well, but it's left for you to figure out if it is positive or multiplication. So don't allow me to confuse you, because that's my goal right now. So, ladies and gentlemen, with this number 10, number 10, we've come to the end of this class. Thank you very much. Thank you, thank you, thank you, thank you, thank you. We are done.